Radek from Epsilon Research and Development Team at Ethereum Foundation. And today I want to talk to you about some extension we're going to add to the Ethereum virtual machine in the near future. So the idea has a couple of years already, and it was initiated by some core devs to improve the way how the cryptography is handled, or cryptography-related functions are handled in the EVM. And the main reason was to avoid adding or limit the need to adding new precompiles. Yeah, but before we get into the details, I would like to make some simple introduction and explain the reasoning behind EVM Max. So what's the EVM Max? So EVM Max translates to Ethereum Virtual Machine Modular Arithmetic Extension. It's a set of new modular arithmetic instructions which support every sized capped, which is important, odd modulus. At the current spec, we define addition, subtractions, and multiplication. We also consider adding exponentiation, which is helpful for calculation some more advanced modular arithmetic functions like modular inversion or square root. One very important thing which should be noticed here is that this proposal is built on the top of the EVM object format, which we had just a presentation of in a minute, and also there was one presentation made by Dano on Tuesday. So EVM Max makes a usage of EOF immediate arguments and the validation of the immediate bytecode also. And it makes it possible to validate EVM Max code before the deployment of the contract to the chain. But I'm not going to get into details of this validation because it's not the main topic of this presentation. Yeah, but it's worth mentioning that EOF is a crucial dependency which makes EVM Max easier to implement in an efficient way. It doesn't mean that EOF is a dependency which has to be before. It just makes the implementation of EVX much easier in an efficient way. So, but where exactly EVM Max is located in the cryptography-related EVM stack? So we have a basic operations in the modular arithmetic on the bottom level, which are used to implement the second level, the elliptic curve cryptography primitives like point addition, multiplication, and more advanced like pairing verification. And these primitives are used to implement ECC algorithms like signature verification and Zk-related functions. But EVM Max implements only the bottom one level on this diagram. As the Epsilon team, we also use EVM Max to implement the second level to make sure that the set of instructions of EVM Max is and the API offer write abstraction and efficiency. So, sorry, too fast. What is going on? Yeah, okay. So we now know what EVM Max is in general. So one of the reasons I already mentioned at the beginning of the presentation, but there are a couple more reasons I want to list. So in the Ethereum community, there is a need to make the implementation of the cryptography in EVM much easier and efficient. Well, it's getting easier and efficient. So with EVM Max, we won't need to wait for a specific precompiles to be, okay, thank you, to be delivered in a fork. We also would like EVM Max to be a tool which allows to avoid adding new precompiles in the future. It will make the core devs' lives much easier because they won't need to maintain the very specialized cryptographic libraries in the EVM. So they will not have a headache like what exactly this function do. I'm not the cryptographer exactly, or we don't have a specialized cryptographer in the team. So why do we need to maintain these complicated libraries, which we take basically very often from some external libraries which are already implemented. But so EVM-Max will deliver a tool which should make precompiled specification also possible in the EVM-Max bytecode. So we can imagine if the precompiles for some reason will be still needed to be implemented and to use by the EVM, we can imagine that the EVM-Max bytecode can define a specification of the precompiles, how they should be implemented exactly. Yeah. So, but let's get a little bit deeper into the EVM-Max instruction details. So, we can split it into three different parts. So, the first part is is responsible for setting up the EVM-Max context. The second one is just the set of modular arithmetic instructions I already mentioned, and the third one is responsible for EVM-Max context communication. So let's get into details of these three parts. So first, setupx creates the EVM-Max context if it doesn't exist yet, which means it initializes modulus values and allocates EVM-Max value slots in the dedicated for EVM-Max memory only. These slots can be only accessed by the EVM-Max, of course, and also initialize some specific constant values, like for example R², which is used by Montgomery form. In this context, if the context is already defined, so the setupx just only switch to this already defined context. Second part are the arithmetic instructions. So basically, they perform the arithmetic operation according to their names, as you can see. So everybody who know a little bit about the arithmetic, modular arithmetic should be able to know what they exactly do. But it's worth noticing that they operate only on indexes of the slots in the EVM-Max context. So the indexes are static and can be validated on the deployment, before deployment of the contract to the mainnet, which allows to validate them using exactly the same way as all the immediate arguments in the EOF are validated. And the last but not least part is there are two instructions, two opcodes responsible for loading and storing values from and to EVM-Max context. They allow to initialize slots values using EVM memory and loads a result back to the EVM memory. Because we allow any size of the modulus, or capped of course, but any size, we transfer values from and to EVM memory instead of EVM stack. So this is the set of EVM-Max instructions, and but of course it can be extended or changed as the proposal is still in the design stage. Sorry, I need to take some water. Yeah. So we have this set of these 5 instructions, which are quite simple. Yeah. So as I mentioned earlier about the precompiles, they have some downsides. I'm going to present also. Yeah. But let me explain what exactly I have in mind. So at first, they are all implemented by many different libraries in different languages across all the execution layer clients. This means that they are potentially vector of attacks on the clients and on the consensus of the chain. Moreover, the IPs proposing new precompiles cannot spec out the implementation details of them because the implementations differ between the clients. As a result of this, very often precompiles implementation need to do some redundant operations to make sure that the result will be exactly the same for all possible implementations of the precompiles. So, because if the result will be different, we can have basically if the result for the same input will generate different will be different, it means that that basically we have a consensus problem, yeah, because we get different results for the same input for the same precompile on a different clients. And we have even recently very intensive discussion about exactly this problem when finalizing the spec of the BLS precompiles, which is going to be introduced in the upcoming fork. Yeah. So and let me show you one example, very simple example of the precompile which already exists. It's a point addition on BN254 elliptic curve. And I'm just going to present you a simple formula which is used to add 2 points on the elliptic curve, not going into details because it doesn't matter how the addition is defined and why it's this way. The formula is quite simple. We've got 2 points on elliptic curve. We first check that the x-coordinates are of them are different, and if they are not, we switch to the special case, which I'm not going to present because it's very similar and doesn't change anything in what I wanted to focus on here. Assuming that the points have a different x-coordinates, we calculate the slope of the line, intersecting these 2 points, and based on this, we calculate third point, where the line intersects the elliptic curve. The point addition definition tells that at the last step, we have to negate the y-coordinate value to get the final result. This is the definition of the point addition on the elliptic curve for this exact case when we have a different x-coordinates. So this is a simple formula, very simple formula, and let's focus on what and how many operations we have to do to calculate this. So, as we can see, we have like 6 subtractions, and 2 multiplications, which are basically the operation which we already have in a set of the EVM max instructions. But there is one more additional operation, which is the division, and basically it's marked with the red color. So, but let's get deeper, a little bit deeper, how the division can be calculated in modular arithmetic. So, as you expected, it's very expensive, and it's very expensive. And if you use some well-known method to calculate this using AddChain, for example, tool, it requires about 300 multiplications. So, comparing to 2 multiplications we have on the previous slides, it's 300 to calculate the division in the arithmetic, in modular arithmetic. But the good thing is that in real world, we wanna add more points to do this. But in real world, when we are adding more points, so the sequence of points, we never make a division every addition we do. So every 2 points we don't do every division at any step, because it can be done in a different way, which allows to make 1 division at most if ever needed, if any needed. So with EVM Max, we would be able to implement the points addition in the optimal way without redundant operations and return the results in any form needed for a specific case. So, yeah. So, sorry. Let's get back to this slide once again. So the solution is just to, one of possible solution is just to use in different coordinate system, like for example projective or Jacobian coordinate system. But also there are algorithms which add a sequence of points in affine coordinates, and you can make a 1 division in the end. So, but what are the benefits of EVM Max over precompiles? First of all, we improve efficiency because of the reason that I already mentioned. We have also more flexibility because we can implement the cryptographic algorithms according to the specific needs. We also improve security as we mitigate potential consensus risk. the complexity of the precompiled implementation details is moved from the EVM to the smart contract. And at last but not least, project can, and last but, sorry, where was it? Okay, and last but not least, project can deliver functionality they need faster, not waiting until the specific precompiles will be processed and delivered to the main chain. So as a summary, I would like to give you an update of what we did till now. So we prepared a bunch of EAPs, and more EAPs are in progress. We have an experimental implementation of EVM Max instructions support in the EVM1, so our project we developed from a very long time. And on top of this, we implemented a couple of precompiles by generating EVM Max bytecode. And it appeared that the implementation is faster than implementation in libff, which is still being used by some of the execution clients. Honestly, libff is not the fastest library available, but that it's still used to implement the existing precompiles already by some clients. And thanks to Jared from GEF team, we also recently prepared a draft of the specification of the vectorized version of EVM Max opcode, which is a direction we wanted to investigate as a potential improvement of efficiency of the implementation of the Poseidon hash function and smaller modulus setup. So what we plan to do next? We need more use cases for sure to make sure that the spec is correct and the API is convenient. We plan also to start supporting different modulus, which will be the power of 2. Some attention also and research on SIMD, SIMD instructions is also, extension. It's also required to utilize this extension if it gives measurable benefits. Regarding the tooling, we work on supporting EVM Max in higher level languages, like for example, Yule or Huff. We haven't chosen yet which one, but now we are very close to start with Yule. We plan also to research the idea of using EVM Max bytecode as a spec language, as I mentioned already, for the precompiles if they still will be needed for any reason. It should also result in a tool to transpile this EVM Max bytecode to higher level language, so basically opposite way, which can be used as a precompile, future precompile implementation by the execution clients. Yeah, so regarding our goals for the very near future, we plan basically the most important is to finalize the EVM Max spec. Then to finalize the EVM Max spec. Then when it's implemented, it will equip the EVM in a cryptography-friendly toolchain, and it should minimize the need of adding new precompiles, as I mentioned already, and make the EVM more ZK-friendly. We want to be from the very beginning of the EVM existence almost, and we plan to introduce this ideally after fork when the EOF will be introduced. So hopefully next year or 2026. And if you are interested in and have more detailed questions and will not be able to ask them now, this is the list of the people I'm aware of who now work on the EVM Max, and this is Epsilon team I'm a member of, Jared from GEF, and Kev from ARG team at TF. Yeah, so thank you for your attention. It's time for some question now, if you have any. Thank you.
Thanks again for this very interesting talk. So let's start with our questions. The first question is there a chance that all these extensions end up being not enough? What about going in the opposite direction and integrate something like a WASM and then implementing it at the contract level?
Yeah, so it always can end up with being not enough if there will be some some use case which we haven't covered when designing the instructions. But yeah, so that's why we're trying to do all these use cases. And also the newest one, ideas like Poseidon hash, like any others. And regarding WASM, I'm not sure I fully understand, but yeah. So the WASM idea to use it to replace EVM was investigated like a couple years ago by my friends from Epsilon. I don't remember now exactly the reasons, but it wasn't finally appeared to be a good direction.
Okay, let's go to the next one. So, the next one is the second one. So, EVM Max is kind of another coprocessor. Why not just enable restricted WASM? Kind of similar question, I guess.
Yeah.
Only unsigned the int sequence of add, mul, store.
Yeah. Yeah, that's another. So okay. Now I remember one reason why WASM is not the best idea here. First of all, WASM, as far as I know, but I can be wrong, doesn't operate on the registers bigger than 64 bits, and basically it makes the implementation of the 256 bits values much more complicated than it can be done now in the EVM, and this also means that yeah. So basically, this also means that in the end, when my friends from team were trying to use WASM instead of EVM, it appeared to be basically less efficient than EVM.
Great. So is it a problem if different implementations of a precompile vary in performance? If so, how to avoid it?
So basically, when we have EVM Max, we will not have, hopefully, we will not have new precompiles anymore. New precompiles related to elliptic curve cryptography or basically to cryptography. So we won't have this kind of a problem. But there is a problem now with the precompiles already. And basically, it means that when we're designing the gas schedule for the precompile, we just need to make it based on the less efficient available implementation in the client execution and the layer execution client.
Okay, so does adding new instructions require a hard fork, a new EOF version, or both?
Yeah, it will require hard fork. It will not require EOF version bump.
Mm-hmm. Are you foreseeing any ways for anyone to exploit these extensions in a non-cryptography way?
Actually, I personally hadn't thought about it, but probably some guys from Epsilon team will be able to answer this question. So we are basically here, so we can find us. Sorry, because I don't know this one.
Can extensions like this be added freely, or is it bad to have too many extensions? I guess something similar to EVM Max, but for another target.
Basically, if it will be needed, it can be added. But you know, the process of adding new extensions is like well known and straightforward. You need to propose it. You need to fight for this on ACD calls, and maybe finally it will be introduced.
Mm-hmm. So if implementing EVM Max in another language, I guess not C, not Go, or not Rust. Are there potential performance differences then?
Yes, definitely. Definitely, it can be a performance differences in the implementation between the clients, like probably for every other instructions which are implemented in different languages across the clients. Regarding yeah.
Yeah. So, do you want to pick one more?
Yeah. So regarding this question regarding SIMD. It's a new topic. We haven't investigated it very deeply, but basically this extension we plan to be used only for smaller moduluses, like 64 bits, which will probably make much more sense here.